Let's look at some ways to create a sample space display for independent events. First, let's talk about independent events. Just to clarify, this is the kind we're going to deal with this unit. If you flip a coin 3 times, each flip of the coin is an event. These are independent events because one flip of the coin doesn't have any effect on the possible outcomes of the next flip of the coin. If you spin a spinner and then draw a card, those are also independent events because the spinner outcome doesn't do anything to limit or change the outcomes for drawing a card from a deck. Here's where we get into something different. If you choose 2 different primary colors, then that's 2 events. You've got primary color number 1 and primary color number 2. As you know, we have 3 different primary colors available, right? There's yellow and blue and red. If I'm to pick 2 different primary colors, I have 3 choices for one of the colors. But once that's chosen, I can't choose it again because then they won't be different. So the second choice only has 2 colors to choose from. These are dependent events. Pull a pair of black socks out of a box of black, blue, and red socks without replacement. Anytime you see without replacement, this is going to be dependent events. Here's why. After you pull the first sock, you set it aside and pull from what's left for the second sock. So the probability has actually changed when you pull that second sock, and those are dependent events. We're going to focus on events like this, the independent events, for this whole unit. Here's a probability event. Toss 2 coins. The sample space is what we call the collection of all possible outcomes, and we need to always know how many possible outcomes there are and what they are so we can calculate probabilities of different outcomes. So the sample space itself is a list of all the possible outcomes. I'm going to show you a few ways to write sample space displays to show clearly what the sample space is. Okay, so if I'm tossing 2 coins, let's say this represents coin number 1. The possible outcomes are heads and tails. And this column can represent coin number 2. So it also can be heads or tails. All right, now that we have the outcomes for the separate parts of the event, we combine them. Heads, heads is one possible outcome. Heads, tails is another one. Tails, heads, and tails, tails. There are actually 4 outcomes. This is the sample space right here. The table is the display. The sample space has 4 items in it, and that's going to be significant when we calculate probability. Okay, you could also do this with a tree diagram. You would say coin number 1 has 2 possible outcomes, heads or tails. And after it is flipped, there are 2 outcomes for the second coin. So heads or tails again. And then this leads to 4 possible outcomes. So it's just a different way of displaying the sample space. In this diagram, this is the sample space. And the tree diagram with that is a display of the sample space. Here's a little more complicated event, rolling 2 dice, classic probability experiment, right? So for this one, fill out a row for one die and a column for the other one. There's all the possible outcomes for each die, and then you combine them by filling in the table. Here's all the possible outcomes for a pair of dice. You can see that some things look very similar, like you could get 4-2 or 2-4. It's important that that's in there twice though, because actually rolling a 2 and a 4 is twice as likely as getting, let's say, snake eyes. Okay? So the sample space is all the pairs of numbers, and the display is the table. A table is often a really great way to show the data without forgetting anything. Here's a different kind of experiment. Spin a spinner with 5 numbers, and then flip a coin. So we've got 5 outcomes for the first event and then 2 for the second one. So you can fill out your table like this and then combine those. And there's all your sample space. You could have filled out the chart in the other direction. It makes absolutely no difference. So we could put heads and tails across the top and numbers going down the side for the spinner. And you would just fill it in the same way, etc. You get the idea. So making a display that shows the sample space is pretty simple. Good luck.